Brazing, quite simply, is heating two metals up to the melting temperature of another metal. So if steel melts at 1800 degrees, 2100 degrees, depending on the steel, and you heat it up to 900 degrees, you could melt silver into the space between those two steels and bond it with silver. If you heated it up to 1300 degrees, you could melt brass into the space between those two metals, those two steels, and sort of glue it, if you will, with a molten brass.
So now we're going to do brazing with an oxyacetylene torch. We're going to be using brass, which is, it has a higher melting temperature, it's a little stronger, and it fills a bigger gap, and clearly we got some big gaps to fill, so that's a good thing. Silver, you really need a super tight tolerance.
You have an oxygen tank, which is green. You have a black tank, which is your acetylene. Acetylene is highly flammable gas, and you open up the acetylene first and get it lit. You have, your color-coordinated tubing that comes from those two tanks. They have this critical point here, which are regulators. One of them tell you how much gas is left in the tank, and the other tells you how much is flowing through this nozzle, how much pressure there is. You're regulating how much is flowing by these two valves, but how much you set that's coming from the tank is here. Paint fumes is no good, and not cleaning it off creates a lot of impurities in the welds. So we do want to get off these. So this is just using an angle grinder with a special tool that is a whole series of abrasive wedges that really do a nice job of removing paint.
Alright, so I'm turning on the tank. This is the acetylene. And there's the oxygen. And so the gauge that comes up when you turn that on, these are loose, these are how they should be left, is totally open, the regulators here. This shows you how much is in the tank. So I'm going to start with the acetylene. I'm going to crack the valve just a touch. I'm going to turn this in, and as I turn it in, see the pressure goes up. Use about 5 pounds on the acetylene. Turn that off. Crack the oxygen. Use about 15 or 20 pounds on the oxygen. Turn that off. Alright, so the regulators are set. We're going to fine tune it with these knobs here. Before I light it though, you should have your mask in place. So the oxygen is cracked just a touch, and now I'm opening up the acetylene, and I'm striking it, and then I'm going to slowly turn on the oxygen. This is where you want to have your mask down, because it'll get a lot brighter. And what I'm shooting for is a neutral flame where those cones match. So as I pull back the oxygen, and that's a hotter flame than I need for this, so I'm actually going to turn down the oxygen a little bit, give myself a little bit of a cone. Silver melts at a much lower temperature, and also if you're dealing with really thin tubing, you just don't need that much heat. So this should be fun. We'll see how it goes. So what I'm going to do is just warm this up a little bit from all sides. So you get starts glowing red pretty quick. And I'll stick that in there. So we get plenty of flux. The brass is only going to flow where the flux is. I can put flux directly on the rod, and I will, but it's hard when you're trying to get good penetration inside the joint. It's difficult to get it in there unless you have a lot of flux in it. So we're just going to be tacking the bottom half here so you can see how everything's going to fit together. So I'm going to move the flame around so I can heat the whole area. Now the edge of this outer piece is going to get hot a lot faster than the solid bit of the interior piece. So I'm going to put a little bit more heat on that one. I'm not trying to do the whole thing right now, so I'm just going to focus on this area. And as it starts to glow red, I can get my brass in there. And you'll see if it'll pull away from the gap because it's actually pulling inside. See how that melts?
Torch ready?
We'll go. So I can just push this rod in, and it's just going to keep. And if I pull the heat back like that, the brass will flow inside the joint towards where the heat is.